In this video, I want to talk about something called the product rule. And the product rule is just a way for us to differentiate things when they're in factored form. So this example you're seeing right now, where I've written, where I've written underneath, differentiate the following: y equals to 3x squared plus 1 in brackets multiplied by 2x minus 3 in brackets. And the way we could differentiate this is using the product rule. And the product rule is simply just if we had f of x multiplying g of x, right? And we just differentiated this, we would get f prime of x multiplied by g of x plus f of x multiplied by g prime of x, right? And you can just treat it, those different binomials as separate parts and just differentiate accordingly. So you may be wondering, okay, where the hell did you get this from? How come, this leads to this? And I'll show you right now. So it's not a made up thing. It's definitely a real thing with some mathematical rigor behind it. So I just said let y equals f of x times g of x here in step 1. In step 2, y prime equals 2. I used the difference quotient and I just plugged it in. So remember, the difference quotient is just the limit as h approaches 0, of some function, let's just say L x plus h minus L of x over h, right? Same thing, but now I'm just plugging it into, f of x and g of x. I did that accordingly. Then I just did some algebraic manipulation. So the writing in pink here, I added in f of x times g of x plus h, and I subtracted it. And I did this just like how you would do something like to get what you want. And that doesn't make any sense, but if you think about completing the square, for instance, right? You would always add a value or add a certain thing and then subtract it to make sure it remains equal. So you can, end up expressing the quadratic in the way you want it. So I just did some manipulation right here. Right? I just did some simple factoring after that. I grouped the g of x plus h terms that were multiplying by that and also the terms that were multiplying by f of x. I just split it up. So I just split up the entire thing, put brackets around it. This part, this part is just the same as this, what was going on. This part is still the same as just what's going on here. Zooming out a little bit, and then I just applied the limit properties. I multiplied it by everything, right? And so on. That guy, and then that guy. And then the limit of, well, this, right? This looks very familiar. That just gives you f prime of x. This is multiplying by h approaching 0 of g of x plus h. You put in 0 for h, you just get g of x. And then the limit of h approaching 0 for f of x, you just get f of x because there's no h value. And then this, looks very similar to, what we've seen before, and that's just g prime of x. So that is the mathematical, proof behind it. So that is the product rule. And now let's, do some examples using it. So hopefully you've written it down somewhere so you can look, refer to it as we do this. So I'll try to be as slow as I can and clear as I can. So we can treat this binomial as f of x. We can treat this guy as g of x and start. So differentiating 3x squared plus 1. So the way we would do that is, I'll just write it out. For this first one, I'll take it nice and slow. So I'm going to write 3x squared plus 1, differentiating this. This is a little apostrophe. 2x minus 3 plus 3x squared plus 1. And then 2x minus 3, differentiating that guy. Now differentiating 3x squared plus 1, if we differentiate 3x squared, that just gives us 6x. The plus 1 turns into 0, and then 2x minus 3, we keep it the same. If that was too fast for you, remember the power rule. We're just swinging over the exponent, right, and then subtracting it by 1. So 2 minus 1 is 1. We don't need to write that exponent. When we swing over the 2 towards, when we're swinging over that exponent, it's multiplying by the 3, so 2 times 3 is 6. Right, now we have 3x squared plus 1, differentiating 2x minus 3, that's just 2. Expand this, 6x times 2x, that's just 12x squared. 6x minus 3 is just negative 18x. 2 times this, x squared, 2 times that, 2. 12x squared plus 6x squared over here, that's just 18x squared minus 18x plus 2. And that is the derivative of this. Let's try this other example here. Pause the video and see if you can figure this out. So, y prime, I'm going to differentiate this first guy here, right? Because I'll make this the f of x term and then this the g of x term, right? So differentiating this x squared, that's just 2x. The negative 2x just becomes negative 2. Constant, negative 3 just becomes 0. X plus 4 plus, and then I write x squared minus 2x minus 3 again. Now I'm going to differentiate x plus 4, which is just 1, because the differentiating x is just 1. 4 is a constant, so it's just 0. Now I'm just going to expand this guy. 2x times x, 2x squared. 2x times 4 is 8x. Negative 2x, negative 8, plus x squared, and I'll keep it in brackets to not confuse you. X squared minus 2x minus 3, right? And now 2x squared plus x squared is 3x squared. 8x minus 2x is 6x. 6x minus 2x becomes 4x. Negative 8 minus 3 is just 11. So 3x squared plus 4x minus 11. Not too bad. Third example. One more to go after this. We're almost near the finish line. So we have 3 terms here. It's not too difficult. All you're going to do, you can make a choice. You can either multiply these 2 terms, or you can multiply these 2 terms and then start differentiating. So I'm going to multiply this and make it my f of x, and then I'll make this guy my g of x. So y prime equals to, not going to do that yet. So I'm just going to expand that. That's 3x squared. 3x times the negative 1 is negative 3x plus the 2x. That's just minus x, right? 2 times negative 1 is negative 2. 3x squared minus x minus 2, and then we have 2x plus 5. Now we can start differentiating. So this first term, I'm going to differentiate, right? This is the f of x term. This is my g of x term. So this is just 6x minus 1, 2x plus 5, plus 3x squared minus x minus 2. Multiply 2x plus 5, the derivative of that, that's just 2. Okay, multiplying all these things to expand it. 6x times 2x, that's 12x squared. 6x times 5 is 30x minus 2x minus 5 plus 3x squared times 2, 6x squared minus 2x minus 4. Right, just expanded this guy over here. Now simplifying, 12x squared plus 6x squared is 18x squared. 30x minus 2x is 28x minus another 2. This becomes 26x. Negative 5 minus 4 becomes negative 9. So 18x squared plus 26x minus 9. That is the derivative of that one. And then finally, we'll just do the work over here because I wrote into the space here. Pause the video and see if you could figure this one out first. So I just threw this one here to mess with you. Not very difficult. First thing we're going to do is just make it have, 2 separate, 2 different binomials. So I'm going to expand this guy and I'm going to expand this guy. So expanding this f of x guy and this g of x guy, right? So this could be x squared minus 9. And this other is just x squared plus 2x plus 1. Not too bad. Taking the derivative. this would just be 2x, right? I'm just differentiating this, multiplied by x squared plus 2x plus 1 plus x squared minus 9. I'm going to take now the derivative of this, 2x plus 2. Multiplying everything, 2x cubed, 2 times 2, 4x squared plus 2x, put it in brackets, plus 2x cubed plus 2x squared minus 18x minus 18. Right. Okay, we add them all up. 2x cubed plus 2x cubed, 4x cubed. 4x squared plus 2x squared, that becomes 6x squared. 2x minus 18x is 16, negative 16x, and then minus 18. So 4x cubed plus 6x squared minus 16x minus 18. That is the derivative of that. So hopefully this was helpful. I wasn't too fast. You know, with my steps and everything, I tried being as clear as I can, but a lot of this just comes with practice, you know, nothing too crazy. The next video we'll talk about the quotient rule, so, you know, another way to differentiate. And yeah, that's pretty much it.